Okay, for this next part, we're going to be condensing logs. So we're basically going backwards from when we were expanding. So our goal now, when we're condensing logs, is for our final to have a single log expression without coefficients. So if I look at number 1, example 1, these two logs are being added. So we're going to use the product property. And we're just going to go backwards to combine them. So we have a single log with the same base, 2, and then we're going to multiply our arguments. So 4 times y. So our final answer is log base 2 of 4y. For number 2, we're subtracting. So that means we're going to use the quotient property. And when I combine these into a single log, I'm going to divide my arguments. So we have a log with a base of 10 of 3/4, or just log of 3/4. Okay, number 3, we have a single log already, however it has a coefficient. So I need to rewrite this coefficient as an exponent using the power property. So my answer would be log base 4 of 5 to the power of 2, or 5 squared. And if you're just expanding or condensing, you can leave it like this. Eventually, when we get to solving, you'll want to go further and actually square that. Okay, let's look at some slightly more difficult examples. On number 4, notice we're adding all 3 of these logs. So when I combine them, I'm going to write it as a single log, base 2, and we'll multiply all of our arguments, 2 times x times y. So we're using that product property. We're just using it twice and combining all 3 into a single log. For number 5, let's stick with PEMDAS. We're going to work inside of our parentheses first. So if I'm subtracting, I'm going to use the quotient property, and I'll go backwards and combine these. When I combine it, it's a log still base 10, and then we're dividing x divided by 5. So divide your arguments. We still have a log of 3 here that we're adding. So then we're going to use our product property to combine these two logs. If it's addition, we're going to multiply our arguments. So 3 times x over 5, or just log of 3x over 5. On number 6, there's 2 different ways I could look at this one. I could look at it as working inside the parentheses first, so combining those 2 logs, and then dealing with my 4, or I can distribute the 4. I'm actually going to show both ways so that we can see we still end up with the same answer as long as you're doing all the properties correctly and using all of your math properties that you've learned in the past. So we could distribute the 4 to both log expressions, which would give me 4 times log base 2 of 2 plus 4 times log base 2 of z. So I use the distribution property of multiplication. And then we can rewrite our coefficients as exponents using the power property. So then we get log base 2 of 2 to the 4th plus log base 2 of z to the 4th. And then we can combine these using our product property. Since it's addition, we combine this into a single log, and we're going to multiply our arguments. Now you can leave it like this, or we can write it as 2 times z with parentheses to the 4th power, since they're both being raised to the 4th power. We have a single log, no coefficient, so we know we're finished. We could have also done this by starting with our product property and combining what we had in parentheses, and would become log base 2 of 2 times z. We would then use our power property to raise everything to the 4th power. So we're using the power property. So we have log base 2 of 2z to the 4th power. Now the catch here is you have to remember those parentheses because 2 and z are both being raised to the 4th power, not just the z. Okay, we only have a couple more. On number 7, notice we have different coefficients for each of these log expressions. So because of that, I cannot combine these logs yet. I first have to move my coefficients, rewrite them as exponents using the power property. So we have log base a of x to the 1/2 plus log base a of y cubed minus log base a of x squared. We can then use our product property. Since they're all the same log at this point, they're all log base a, and I can combine all of these. So the first two are being added, so we're using power property. Log base a of x to the 1/2 times y cubed. And then we're going to have to use our quotient property. If we're subtracting this log, we're going to divide by our argument, or our x squared. It's okay for you to leave this. It's a single log. We don't have coefficients. Just know when we get into solving, eventually you'd want to reduce this. Since I have x to the 1/2 on top and x squared on bottom for my fraction, if I'm dividing with like bases, remember you subtract your exponents. So we'd end up with log of y cubed over x to the 1/2, or x to the 3/2. Okay, for number 8, notice we're subtracting again. I'm going to start by just using the quotient property on the first two to combine those two. Before I can do that, we need to move our exponents. Since 3/2 and 1/2 are different, and the 6 is different, we'll use our power property to rewrite our coefficients as exponents. So we have log base b of 2 plus x to the 3/2 minus log base b of y to the 1/2 minus log base b of z to the 6th. And then, like I said, we'll combine the first two first. Since it's a quotient property, when we combine these, log base b, we're going to divide our arguments. So 2 plus x to the 3/2 divided by y to the 1/2 power. And we still have our minus log base b of z to the 6th. Okay, now I'm going to combine these two logs. We're subtracting. So again, we're going to use the quotient property. So we have log base b of 2 plus x to the 3/2 over y to the 1/2 divided by z to the 6th. I have a fraction inside of a fraction. We definitely don't want to leave our answer in this form. So we need to go ahead and make our z to the 6th a fraction. And when we're dividing a fraction by a fraction, remember you multiply by the reciprocal. So we're going to multiply times 1 over z to the 6th. So our final will be log base b of 2 plus x to the 3/2 over y to the 1/2 z to the 6th. Now, one thing we could have done to avoid all the fractions inside the fractions, at the very beginning, since they were both subtraction, we could actually have factored out a -1. So I could have rewritten this, and I'm going to go ahead and do this in green. So I could have had this as 3/2 log base b of 2 plus x minus, and then in parentheses we would have the 1/2 log base b of y plus 6 log base b of z. So I factor out a -1 from my second and third.